Hi guys, I'm gonna walk through this practice assessment for chapter 9 that I gave you guys, and I'm gonna go through each question. Feel free to watch the whole thing, or feel free to just fast forward to the parts that you guys care about, the ones that you missed or the ones you were confused on. Okay, so question number 1 said, if two similar figures have a linear scale factor of 1/2, what is the volume scale factor? So in this one, we just have to remember that if we have a scale factor, that the area and the volume don't change the same way as the sides do. So in order to get how the volume changes, we take that scale factor and we cube it, and that gives us our volume scale factor. So if we had a linear scale factor of 1/2, we're going to take that and we're going to cube it. So then 1/2 cubed becomes 1/8. So the volume scale factor is 1/8, and that's what it's changing by. Okay, question number 2, it gave you this solid and I wanted you to make a map plan for this solid. So remember, we do map plans where this is the front side and this is the right side for all of your guys' diagrams. So you just have to look at what boxes are filled in. So in the front left corner, you have 1 box, and then it continues as 1 all across the front. So if I look at the patterns that I have in these ones, A definitely can't be it because it doesn't have 1 all the way across the front side right here. Okay, and then you just have to keep looking. So let's see, if we go backwards now, this next block is a 1. So that means this one can't work because it has a 2 right there. And then the difference between these is the middle block is a 2 or a 3. So if I go back up to the top, this middle block right here has a height of 3. So that means the correct answer has to be B. So this is my correct map plan if this is the front side and the right side. Okay, question number 3 was just what's the volume of that? So you take all of those numbers in the map plan right there, you add all of them up, and you should get that this volume has a volume of 12 units cubed. So your answer for that one should have been 12. Okay, when we're doing surface area of prisms, remember surface area has the formula where you're doing the perimeter of the base times the height plus 2 times the area of the base. So what we have to do is we have to determine what's the base. So this triangle is my base because it is the thing that is being repeated over and over again. And then my height is the height of 10. So that's how it's going backwards as a height of 10. So this side's 20. So if we just fill this whole thing in, we've got surface area equals the perimeter of my base. So my base is 16 plus 12 plus 20 times the height, and in this case that's 10, and then we're going to add to that 2 of the bases. So the area of the base is a triangle, so that's 16 times 12 divided by 2. And if I plug all of that in my calculator and start simplifying, 16 plus 12 plus 20 becomes 48 times 10 plus 2 times, let's see, if I do 16 times 12 times 2, or divided by 2, let's see, what does that become? 16, oops, times 12 divided by 2. We get 96. So this is going to be 2 times 96. And then this becomes 480 plus 96 times 2. So 192. So 192 plus 480 gives us 672. So total surface area for this is 672 centimeters squared. So then that should be your correct answer right there. Okay, volume is a little bit less work. To find the volume of a prism, we do the area of the base, which we represent as big B, times the height. Okay, so area of the base, remember this triangle right here is our base. So to get area of the base, we do 16 times 12 divided by 2, which we got was 96 up there. And then to find the volume, we just do 96 times our height, which in this case is 10. So then our total volume is 960 centimeters cubed. So then your total answer should have been 960 centimeters cubed. Okay, so this is getting back into scale factor. So it says a triangular prism has a volume of 70 cubic units. The prism is enlarged with a linear scale factor of 3. That means the side lengths are changing by 3. Remember, the volume doesn't change by that same scale factor. So if the scale factor is changing by 3, that means the volume factor is going to be that scale factor cubed, which ends up being 27. So to get our new volume, we take the original volume, which was 70, times our volume factor, which is 3 cubed, which is 27, multiply those together, and we get 1,890 feet cubed. So then that's going to be your answer for this one. Okay, I think this one may have had a little bit of a problem on the actual quiz itself, so you guys just want to check and make sure you did this one right. So this one's asking for the volume. So again, volume is just area of your base times your height, and in this case, our base is a circle, so it's pi r squared. The diameter is 10, so that means the radius of this thing is 5. So area of base is going to be pi 5 squared, or 25 pi. And then to get the volume, we take the area of the base, 25 pi, times the height. And in this case, the height is 15. So then if we multiply this together, 25 times 15, we get 375 pi. And we wanted you to leave it in pi, so then you stop there. And this is centimeters cubed. So this guy should have been your answer for volume. Okay, now we're doing the same shape, but we're looking for surface area. So surface area in this case is a little bit different. So surface area is still going to be the perimeter of your base times your height plus 2 of the bases, so your top and bottom. So perimeter in this case is this shape. And that is, or that distance, which is our 2 pi r. So that is our circumference of our circle. So that's what goes in place for the perimeter right here. So our surface area is going to be 2 pi, and again, our radius was 5, times your height, which in this case is 15, plus 2 times the area of the base, and the area of our base is pi r squared, which is pi 5 squared, because remember our radius inside of here was just 5. And then we just start simplifying that out. So let's see, if we do 2 times 5, that becomes 10, times 150, or times 15 becomes 150 pi. And then if I do 5 squared, that's 25, times 2, that becomes 50, so plus 50 pi. Add those together, we get 200 pi, and then we're working on surface area, so this is centimeters squared. So your answer should have been this, 200 pi centimeters squared. Okay, this one's super easy. Finding the volume of a rectangular prism, you just find area of the base, which in this case is 5 times 2. Then you multiply it by the height, which is 8. Multiply all those together. This gives us 80. And then working on volumes, this is centimeters cubed. So the answer should have been 80 centimeters cubed. Okay, this one got you guys a little bit because this is a slanted rectangular prism. So this distance doesn't represent the height. So if you did 8 times 9 times 11, that doesn't give you the actual volume of this thing, because this 7 is really your height, because this is really hitting over here at 90-degree angle since it's slanted. So to find, are we trying to do volume? Yeah, the volume of this thing, you do the area of the base, which in this case is 9 times 11, and then you're going to multiply that by 7. So if I do 9 times 11 times 7, this becomes 693 centimeters cubed. Oops, that was wrong. Make sure you choose the one that says cubic centimeters because we're working on volume. Okay, this one's taking us back into a little bit of review from when we were working with angles and polygons. So this guy is a 5-sided polygon. And the first thing we want to do is find the sum of the interior angles. So find sum of interior angles. We had a formula to find all of them. It is 180 times n minus 2, where n represented the number of sides. So to find the sum of the interior angles for this one, we just plug 5 in for n. So this becomes 180 times 3, which is really 540 degrees. And now we know that all of these angles inside of here have to add up to be 540 degrees. So I just take all of my x's and I add all of those together. So 5x plus 3x plus 5x plus 8x plus 4x, that becomes 25x. And then I add up all of the individual numbers out back, and that becomes plus 40. And then I know all of that has to equal 540. So now I just solve for x, subtract 40, got 25x equals 500, divide by 25. So x in this case is going to be 20. So answer should have been 20. Okay, this one wanted us to calculate the volume of a hexagonal prism, no decimals, leave answers exact. So that should be a hint that we're probably working with a shape that has like a square root of 3 or a 30, 60, 90 triangle in it. So when we're trying to find the area of a hexagon, remember we take this hexagon and we break it into triangles. So I'm going to break it into this triangle. I know this bottom side is 2, so that means this side down here is going to be 2 as well. I'm going to drop a height in here. I know that splits it perfectly in half, so that becomes a 1. Now we have to figure out what this interior angle on the top of here becomes. So I know I have 6 sides. It is regular, so I'm going to take 360 divided by the number of sides and get that this is 60. So the big angle up here is 60 degrees. I'm going to cut that in half just so that I can get the little angle in my triangle. So the triangle I'm going to be working with is 30 degrees up here. This side length is 1, and this is a 90 degree. So then using our 30, 60, 90, because that has to be 60, I know the hypotenuse is going to be double whatever this side is. So this side is going to be 2. And then the height of this triangle is going to be times the square root of 3. So this is 1 squared root of 3. Okay, so then if I'm going back to this triangle, this is what I'm going to use. Base is 2, and we just said that this height was the square root of 3. So to find the area, we do the base times the height divided by 2, because remember it's a triangle, so I think lots of you guys forgot to divide by 2. So then the area of one of my triangles, one of these big triangles right here, is the square root of 3. So then to find the area of the entire hexagon, I multiply this by 6. So the area of my base is 6 square roots of 3. And then to find the volume, all we do is take that area of the base times the height. So volume is going to be 6 square roots of 3 times the height, which in this case is 5. So this becomes 30 square roots of 3 feet cubed, because we are working with volume. So it should be this 30 square roots of 3 feet cubed. Pay attention, you guys. Lots of you guys chose this one, and I said in the directions no decimals. So if that should be a dead giveaway that that's not a right answer. Okay. Christy bought her house at the height of housing boom, paying $800,000 for it. Unfortunately, fortunately, the house increases by 6% of its value each year. What will her house be worth 5 years after she bought it? So the fact that we are increasing by a specific percentage tells us it's going to be an exponential equation. A is what you started with, B is your multiplier, and then X is always going to be in years. So my equation is going to be the house started at $800,000. She's increasing by 6%. So we always put a 1 here. Increasing means we're going to add, and then we take the 6% and we convert it to a decimal. So 6%, we move the decimal back 2 places, is the same as 0.06. So I'm adding 0.06 every single year. And then that's our x. So our equation is 800,000 times 1.06 to the x, where x equals years. So now if I just want to know how much it's worth in 5 years, I plug in 5 for that x right there. And then this does something really weird in your calculator. So I want to take a second and show you guys what it is. So we plug in 800,000 times 1.06 raised to the 5. And then what it gives out, oh, did I not put a decimal in there? Oh no, it gives you a right answer. So then that's your guys' answer is 1070580.46. So then your correct answer is this guy right here. I think I may have put an extra 0 when I was making my answers to this. Okay, this one wants one exterior angle, which is different than an interior angle. So remember, to get an exterior angle, or one exterior angle, we take 360 degrees and we divide it by the number of sides. So I take 360 divided by 13, and that will give me my exterior angle. So 360 divided by 13, and you get 27.69 degrees. So answer should have been 27.69. Okay, 15, it says a square has an area of 81 centimeters squared. So you have a square. The area of this thing equals 81 centimeters squared. Remember, to find area, we just do the base times the height, or the length times the width. And so this is x times x. So in this case, we know x squared is going to equal 81. The only number that makes sense there when I do the square root is that x is going to be 9. So all of the sides of my square are going to be 9. And then I want you to find the diagonal. So we're looking for this diagonal right here. Well, we know it's a square, so we know those are 90-degree angles. So now I can just do the Pythagorean theorem. So I do 9 squared plus 9 squared equals diagonal squared. So I've got 81 plus 81 equals diagonal squared, which is 162 is diagonal squared. Now I take a square root, and then this doesn't come out nice. So we have to find perfect squares that divide in theirs. So I, in my calculator, just start taking 162 and dividing nice perfect squares. So I do 162 divided by 9. And it tells me that comes out to be 18. Okay, then I can see there's another 9 that divides out of here. So that means that 162 is divisible by 9 times 9, or 81. So if I do 162 divided by 81, I get that it goes in perfectly twice. So I can break 162 into 81 times 2. I know the square root of 81 is 9, so that can come out. And then I can't do the square root of 2, that's stuck inside of there. So then my diagonal is 9 times the square root of 2. So that should be your final answer right there, where it says 9 times the square root of 2. Okay, so this one, you guys just have to slow down a little bit, read directions. So it says select all that are possible. So they do give you that these two lines are parallel. So if these two lines are parallel, I know angle D and angle C have to be congruent because they're alternate interior angles. I know that angle B has to be congruent on both sides because those are vertical angles. And then I also know that it's a possibility for A to be congruent to E because they're also alternate interior angles on that, those parallel lines. So there's two cases that actually work for this. So I could have an angle and then a side and then an angle. So I have angle, side, angle for both of my triangles. So it could be this angle, side, angle one, or I could also have it be where I do this angle, angle, and then a side. So then I would have angle, angle, side are both possibilities. So it could also be, or I guess side, angle, angle. So it could also be that one. So you should have selected both of those answers for this question. Okay, last two, and I hope these were easy and that you guys all killed it. So if this is the angle that we're working with, 45 is your adjacent side, K is your hypotenuse, because it's across from the 90-degree, and it's a right triangle, so that means we're doing SOHCAHTOA. And if I have the adjacent and the hypotenuse side, that means that I'm working with the C, which is cosine. So the function I should be using for this one is the cosine. And then last question, same thing. I have 53 is the angle that we're working with down here. This side is the opposite, and this side is your hypotenuse. So if we go back to SOHCAHTOA, the function that has opposite and hypotenuse with it is sine, so then your answer to this one should have been sine. That's it, guys. I hope you did okay, and I hope that it made sense. If any of these problems didn't make sense as I went through, please reach out, and I look forward to hearing from you.